In mathematics and in philosophy, especially analytic philosophy, you'll often hear the words necessary and sufficient thrown around. And I find these ideas can be confusing for some people. So in this video, I'm going to do my best to explain them, explain what they mean and why we use them and when. Now, necessary and sufficient conditions are used to describe relationships between propositions that are linked by a conditional. So consider a proposition of the form A implies B. And as an example, you can let A be the proposition that I can drive my car and B be the proposition that my car's engine is working properly. A implies B is like saying, if I can drive my car, then the engine is working properly. Now, when I say A is sufficient for B, it means knowing A is enough to know B. And this is what comes from that first row of the truth table and from modus ponens. If I know A implies B and I know A is true, then I also know B. So A being true and A implies B is enough to know B is true. In fact, A is sufficient for B to be true. However, it wouldn't make sense to say A is necessary for B. And why is this? Well, suppose I can't drive my car because the tires are missing. In this case, the engine may still be fine, but I can't drive for some other reason. A is not necessary for B because there may be other ways B can be true, even when A is false. And those happen to be those last two rows of the truth table. So let me go ahead and put that truth table there. Here's A, B, and A implies B. Remember, A implies B is false only when the antecedent A is true and the consequent B is false, and it's true everywhere else. So when we say A is sufficient for B, we're looking at that first row in the truth table. And the reason we don't say A is necessary for B is this would be like affirming the consequent. This is a logical fallacy we talked about in a previous video. Once again, it may be the case that I can't drive my car for some other reason, and we haven't said anything about my car's engine working properly being the only thing I need to know that I can drive my car. I certainly need my car's engine to be working properly for me to drive my car, but there may be other things out there that are necessary to drive my car. When we say B is necessary for A, this is the same as saying whenever A is true, B must be as well. So if we know A is true, B is necessarily true by the material implication. And once again, you think about it the other way, you think about it in terms of modus tollens. If we know A implies B and we don't have B, then we know A is false. And this would be like saying, look, if my car's engine is not working properly, I clearly won't be able to drive. My car's engine working is necessary for me to drive it. So this is why we say B is necessary of A when we have an implication of this kind. Now, here's another way to think about it that will hopefully make this a little more clear. Imagine I have some space that represents all the possible ways that things can be. And I have some event, say A, which is representing all the possible ways A can be true. So in my example, A was the proposition I can drive my car. There can be a lot of ways in which the proposition I can drive my car is true. For instance, maybe I'm renting a car in which I can drive that car. Perhaps I bought a different car than the one I own. These are all other possible ways that I can drive my car. And not A is the area outside of this. This is all the possible ways A cannot be true. So maybe I can't drive my car because the tires are missing or because the engine isn't working properly. There are a lot of possible ways. And if I take A's disjunction with not A, based on our rules of logic, this is equivalent to all the possible ways things can be, because either A is true or A is not true, and everything else that happens must kind of conform to one of these different circumstances. So suppose we take A and we have some other event in our world that's called B. And what this is going to do is we're going to be able to think about what happens when A and B are related. So if you have an event that's in kind of the intersection of these, what you're looking at is all the possible ways A and B are both true. And if you're looking here on the left in this blue area, you're looking at all the possible ways A is true and B is not true. And if you're looking in that B section on the right, you're looking at all the possible ways B is true and A is not. So when I tell you that A implies B, this means if I know A is true, I also know B is true. So to match this picture, we're going to need to move B. It's going to go like this. And notice how this only tells me something about B when I know A. If I don't know A, I can't necessarily conclude that B is false. So we need to capture the fact that if A is true, B is also true. But if A is false, it's not necessarily the case that B is true. There are other cases in that truth table where B is true even when A is false. So that would be like this section over here. My engine works, but my tires are missing, so I can't drive. Now we say A is sufficient for B because this means if I know A occurs, meaning I'm inside that blue A circle, I'm also in the region where B occurs or where B is true. So knowing A is sufficient for knowing B if A implies B, because once again, B sort of totally encapsulates A. Likewise, we say B is necessary for A because if I'm not in B, I'm clearly not in A. If B completely encapsulates A, if I know I'm not in B, I know I'm not in some sort of subregion of B, which would be A. So once again, Just because I know B occurs doesn't tell me that A occurs, because there's some regions of B where A doesn't occur. But if I know A implies B and I know I'm in A, I know I'm also in B. Now, suppose we say A if and only if B. Well, this is like overlapping the two circles completely, and this is where we have logical equivalence. A is true whenever B is true, and is false whenever B is false. And this is where we say A is necessary and sufficient for B. A is necessary for B because we know if B doesn't occur, A does not occur. And we say A is sufficient for B because if we know A is true, we will also know B is true. So once again, it kind of works both ways. So anyway, hopefully this kind of cleared it up. Thanks for watching, and I'll see you in the next video where we will talk about the contrapositive.